So we'll start this way. Explain to me why Europa is worthy of this mission. What's exciting about it? What might be learned?
Well, Europa is an ocean moon that circles Jupiter. Beneath an ice shell crust is 60 miles of water. In total, though Europa is only the size of our moon, there's 3 times more water on Europa than there is on the planet Earth. And this is liquid salt water, the same kind of stuff that's in our oceans. So if you took a cup of water or took a cup and plunged it in the water, you could drink it and your body would know what to do with it. It wouldn't be healthy, but you could certainly do it. The the cool thing about Europa, or the important reason that we need to explore it, is because um, in addition to having water, it also has hydrothermal vents at the bottom of that ocean. And so that's providing an energy source. And you also have water touching rock, sort of at the ocean floor. It touches a rock mantle, and that's where you get chemistry. So when you get water, chemistry, and energy, you have the ingredients that you need for life. And there's one more great thing about Europa. Um, it's had time. In other words, biologists believe that it takes more than just those ingredients to make life. You also need a long period of time to sort of bake in the oven. In this case, Europa's had 4 billion years. And that makes
So,
it an enormously compelling object of exploration.
and in some of there's hope that there's microbial life on Mars, maybe still existing in the soil, maybe some other places in our solar system. But the scientists who studied it think there could be actual life, like the equivalent of fish swimming around there.
That's right. Because of the time that life, assuming it took hold at some point in Europa's history, um, uh, 4 billion years is an awful long time for evolution to take place. And so you might have microbial life, but you might have fish, you might have sea monsters. When we look at the bottom of our own ocean, it's a terrifying place, and some animals that you would think are aliens already. Um, the one thing that Europa's had, or has in its advantage, that even the Earth didn't have. Earth has had multiple extinction level events, from asteroid impacts and climate catastrophes, and when all life is basically vaporized from the planet Earth, and Earth starts over, life begins again. Europa hasn't had any of that. So if, let's say, 4 billion years ago, something happened, chemicals came together to make life, and it never had that extinction level event, it might be some pretty interesting things down there.
NASA has created this, you've probably seen it, this really great animation of what Europa might look like. And it starts way down in the water, and it rises up through what seems like 60 miles of ice, as you said, and then it comes up on the surface, really craggy, hostile looking world. And in the distance is Jupiter, which exerts tremendous influence on it. Very exciting to be able to envision it. Um, was there ever consideration of humans going there, or it's always been a robotic type probe that is planned?
That's a really good question. So, because of Jupiter's size and its magnetosphere, and the way the magnetosphere interacts with particles in space, basically Jupiter is surrounded by a halo of death called the Jovian radiation belt, and the conditions there are a lot like the immediate aftermath of a thermonuclear bomb. It's a pretty inhospitable place for human beings. Europa, unfortunately, sits dead in the middle of that radiation belt. It's just constantly marinating in the worst place in the solar system. So the idea of astronauts one day going there, technologically, we're not there, and we won't be there for foreseeable generations. An astronaut that went there today would die immediately of cancer. So robots have always been the ideal way to explore Europa. The problem is, because of the radiation, and because these robots are run by computers, obviously, it tends to give robotic spacecraft quite a bit of trouble. Zeros get flipped to ones, and suddenly a spacecraft that would ordinarily just keep doing its thing decides, oh, let's crash into Jupiter. That hasn't happened yet, but previous spacecraft that have gone to the Jovian system and have had to endure the radiation have had a very difficult time indeed. Galileo, the spacecraft that was launched in the early 90s. I believe it was the early 90s. That's a good example of one.
Describe what the mission, as it's currently envisioned, what this mission would do. The one that's moving forward that you write about in your book, the mission, the name of the craft, how long it would take to get there, what it will do when it gets there.
So the spacecraft is called Europa Clipper, and the name comes from the ships during the Age of Discovery, the fast ships that could go back and forth from the New World to Europe. The reason it has that name is because it's very difficult to orbit Europa itself. So rather than just circle Europa, what they're going to do instead is circle Jupiter. And each time they orbit Jupiter, they're going to encounter Europa in an orbit. And over the course of months and years, they can get Europa in single stripes at a time. And they can just keep doing this until they get a full 360-degree view of that moon. The spacecraft will launch in 2025, possibly. It'll have, as early as 2025. There are still some questions about which launch vehicle it'll go on. It might go on NASA's SLS rocket, which is the largest rocket that NASA's ever built since the Apollo program. The advantage of that would be it could get there very fast because of its power. It's looking like it's probably instead going to launch on a Falcon Heavy rocket, which is built by SpaceX, one of those extraordinary rockets that can also come back down and land. The advantage of doing that is the Falcon Heavy is ready to go, and they've actually done engineering numbers and found that they can take an almost straight shot to Jupiter. They'll launch from Earth, they'll encounter Mars and pick up some of Mars's gravity, and continue the rest of the way to Jupiter. And so that would take roughly 6.5, 7 years to get there.
Among the discussions between NASA scientists that you write about in your book, the idea of landing on not just studying Europa from the orbit of Jupiter, but landing on that moon at some point, and then trying to figure out how to get through 60 miles of ice to find out if little fishies are swimming around down there. So how daunting is that task, and how likely is it at some point?
Right. So that goes back to the last question that you asked. And so when Europa Clipper is doing its scientific observations of Europa, what it's looking for is not life itself. It's looking for habitability, and it's looking for the places on Europa most likely to have life. So once it characterizes the surface, and once it says this, once scientists are able to determine this is probably the best place on Europa, or the place most likely to have a good ice-ocean interface where whatever's swimming in that water could have seen the top, that's where we're going to land. And the next step would be sending a lander there. It would actually touch down on the European surface. It would have to saw into the ice. It has to go about 10 centimeters total to get beneath the radiated ice surface. But once it gets to that 10 centimeters, it's basically a super powerful microscope. That's the simplest way to describe it. And it would start looking for evidence of things that once wiggled in the European Ocean. Beyond that, actually getting to the ocean is a difficult endeavor in our lifetimes. It probably won't happen. There are concepts like melt probes, which would be nuclear power sources that you could basically land on Europa and just let them over time melt down into the ocean below. That's one possibility, but there's another tantalizing method of getting to that water, and that is plumes. So when we look at the orbit of Saturn, there's a moon called Enceladus, and Enceladus famously has these enormous fans of water vapor blasting into space, kind of like Old Faithful almost, but in the scale of tens or hundreds of kilometers out. That's water. It's conceivably from the ocean itself. It could be from lakes inside the ice. So what happens is, as the water ice ocean interface sort of touches, eventually water begins to rise, and dense layers of ice tend to fall. And it's kind of like a lava lamp. It's constantly cycling like that. So there might be big lakes of water inside the ice that come from the ocean. So again, those are little ecosystems that you could touch. Whether the plumes come from the ocean or from those lakes, the cool thing is all you have to do is fly a spacecraft through those plumes. And once you do that, you can take samples from there. Again, it's not going to find life, but it's certainly going to give you a very solid idea of whether the ingredients for life are there and what the nature of that life will be.
You've thought about this for a long time, what the impact of confirmation of life on Europa or anywhere else in our solar system, what it would mean for us. Can you share that with our audience, how profound that discovery would be?
There might be no more profound discovery in all of human history than the discovery of life, non-Earth life in the solar system. Something like Europa is an entirely alien versus the planet Earth. It has similar ingredients, it has similar energy, it has similar chemistry. That those sorts of things would still take place. So it would be life as we know it, but it would not be life that came from our, the common ancestor that all life on Earth came from, which means it would almost be like a second Garden of Eden, in this case at the bottom of an ocean. What does that mean? Well, it would have implications for religion, it would have implications for philosophy, and of course, it would have implications for biology. What would a creature look like that evolved from something that has no connection to us, that doesn't fit in our food chain? What does it even mean to be a human being in a universe with a creature that has no relation to you at all? Is it an equal? Is it a pet? How would you even think of it?
Well, you can bet that immediately you'd have fishermen who want to go there and try their luck in catching some European fish and see what they taste like, for sure. Your book describes the epic struggle it was to get this mission on. And as you have told me in previous conversations, it's pretty much a go, as secure as anything is in NASA land. But you describe all the battles that were fought within NASA to make this happen. There's a quote from the Right Stuff: "No Bucks, no Buck Rogers," because human missions, where we send astronauts to some faraway place, have a lot more political support, a lot more sort of media support. Robotic missions might get a lot more information, but they don't have the same kind of pizzazz. So describe for me, in general terms, the story that you tell in your book about how difficult it was to fight for this mission, the competition with the folks who wanted to go to Mars, and then describe in general terms the people involved in the story that you tell.
Within NASA, there are different sort of interest groups that want to go to different places. And this is because if you're a scientist who studies Mars, or if you're a scientist who studies Saturn, those are very, very different objects of exploration. And there's only so much money. NASA gets 1/2 of 1% of the federal budget. And that's not a whole lot of money, especially relative to the glory days of the Apollo program. There's not enough money to do everything. There's not enough money to go everywhere. And accordingly, the best you can do is choose an object and sort of stick with it and get there. In the case of Europa, it had a really hard time versus Mars. Mars is a lot easier to get to. Astronauts will one day land on Mars. And if you're NASA, you're going to say, where can I get the most bang for my buck? And from an astronaut standpoint, obviously the answer is Mars. Still, there is money that is set aside just for planetary exploration, and scientists do work really hard to figure out who is the most important, or what is the most important place to explore and why. What are the science questions we can answer by going to Europa versus going to Enceladus? To answer these questions, these missions compete internally at the agency. They decide, scientists and engineers build mission proposals. Here is how we would explore Europa. Here is how much it would cost. Here's what we would learn. And other worlds do the same thing. Mars does the same thing. Here's the rover we would build to go to Mars. Here's how it would collect samples. And here's how we would learn about the past of Mars, for example. And those missions are competed against each other internally at the agencies. Independent review boards look at them and say, this mission can fly for this amount of money. It's a safe bet. It's low risk, or it's high risk, but it's high return. And they balance these things out, and in the end make recommendations internally and go forward with that. In the case of Europa, it took almost 20 years to get a mission going from the first notional idea, let's go there, to actually approving a mission. And then finally, by the time it launches, I think it will have been 25 years. So that's that's an entire career that somebody's going to spend just to launch the spacecraft. That's not to get the data. That's not even to get there. Those things actually span multiple careers. So when these missions begin, you've got sort of a graybeard scientist, and they make sure when they build these teams to bring in young postdoctoral graduate students, because they know one day the graduate students are going to be the graybeards by the time we're actually doing these missions. It's an extraordinary thing. Europa has been fortunate in that the team behind this mission, in this case, Europa Clipper, has just been enormously tenacious, both in rallying the science community behind their goals and also in attracting congressional support, in building a constituency within NASA, in building responsible, cost-effective missions that can actually fly. And even then, doing this multiple times, and they've developed 4 or 5 robust, well-considered spacecraft, but even then, very few of them ever got serious consideration, and only one of them eventually was selected for flight.
In your book, you tell, in essence, about going to war against Mars, meaning the people in favor of the Europa mission had to fight against long-standing momentum of people who wanted to go to Mars, primarily as the top priority. You describe a report written by Wernher von Braun long time ago, where he laid out the whole plan for it, and that has sort of been on the minds of NASA for a long time. It's an amazing accomplishment for the pro-Europa people to get this on when NASA has had so much focus on Mars for a long time, right?
That's right. Well, from the inception of NASA, going to Mars was always the goal. In fact, going to Mars was the goal before going to the moon was the goal. The moon was almost, amongst a great many people, was considered a distraction from the real goal. And even today, when we look at the Artemis program versus what used to be the journey to Mars and where do we go next, a lot of people are saying, well, why go to the moon? It's nothing like Mars. We won't learn the things that we need to learn to survive on Mars. We won't learn those things on the moon. It doesn't even have air. So within NASA's DNA, because von Braun was so, not only was he so adamant about exploring Mars, but he developed such a coherent and cohesive mission strategy and broad agency strategy to get us there, or to get land astronauts there. At some almost genetic part of NASA, that's always been the way things are done. And if you look at, although it's taken a very long time, if you look at the cadence of missions and the development of technology, every step of the way, we're just checking boxes that von Braun wrote down in the 1940s. Europa, to overcome that, that was quite an achievement. But it also speaks to the tenacity of the scientists, and it speaks to the urgency of this mission and the stakes of actually exploring this ocean and finding life.
You introduce us to these key characters who played vital roles in making the mission happen. And it's a great personal story, how each of them came from a different vantage point and origin point. If any of them had not been there to make this happen, the whole thing could have fallen apart. They're all key characters. How tough was it for you to gain entry, gain their trust, where they opened up and shared with you the inner workings of NASA and how this happened?
Well, the book took 7 years to write, and a big part of that was winning people's trust, letting them know that I'm actually doing my homework, I'm actually reporting this responsibly, doing the research, spending time with people, and learning not only what's being done and how it's being done, but why it's being done. And that's a very difficult thing, and it's very time consuming. But ultimately, I think that it led to a much stronger book. The agency itself is never super happy to have people poking around, looking at very intimate levels and what's going on there. They're a federal agency, and it's just not the way government works. They shy away from sunlight like vampires. But at an institutional level and at a science level, and of course, a lot of these scientists, NASA doesn't directly employ the people on these missions generally. They work for academic institutions and get research grants to be part of these missions. So I was able to, over the span of many years, I interviewed over 100 people across the country, from California to Maryland. And I was able to build stories. And it was interesting when I was writing this book, something that would strike me. If I were writing a scene, it could be a small scene at some science conference or a small scene just at a cafeteria where people are talking. I might be drawing from 16 different interviews with 4 people. That one interview I did in 2014, one interview I did in 2020, one I did in 2017, different people, and bringing it together one detail at a time and sort of reassembling or taking details and applying them to the mosaic that would be the story that I'm trying to tell. So it was an awful lot of work. It was awful difficult to do, but I think that the detail and the empathy that I'm able to bring to the characters, I think it paid off in the end.
Well, you tell the story that how they all come at this from a different origin point and what motivates them, and it feels like you're a fly on the wall for all these things that are really happening. It's terrific detail. Is everybody okay who trusted you with the information? Are they okay with the book so far? I ask in this context, as you said, NASA doesn't really like people poking around in their drawers and looking for secrets, but you've been able to pierce that veil a little bit and well, quite a bit, and tell of how it works inside the agency, and it's a mess, right? It's a mess.
It certainly is. I was very nervous after I finished writing the book and the review copies came out before the hardcovers come out. Sort of a version for book critics goes out, and also for anybody you might need to send a copy to review facts or whatever. And I was very nervous for the people that I'd been writing about for so many years and who trusted me, because if I had misrepresented something they said or misrepresented something they did, it could kill their careers. I mean, it could be it could have devastating impact. So I wrote the book and I sent it to 3 or 4 people who were part of the mission at the agency headquarters and at the different NASA centers. And I was terrified. And the main scientist on the mission called me, and he was the one I was most afraid of. And he said, I found one word you need to change. In the whole book, 488-page book, he found one word he wanted to change. And so I felt good after that. NASA itself, I have heard from people who work at the agency. They seem thrilled about it. Oh. This is not a hagiography or anything like that. It doesn't give NASA a pass on anything. It's an unflinching look at how things are done, but it's an honest look, and it proceeds from the assumption that everybody there is acting on good faith. And if you start from that, if you believe that these people, nobody's there just trying to throw rocks at people, but they're actually trying to get things done. If you work from that, you're able to sort of see all the sides, and the reader themselves can make a decision on this is what they should have done, or this is what they should have done, or this was the right thing in the end.
NASA is sort of at the mercy of the budgeteers. You know, a new administration comes in, they have their own ideas for how much to spend on the space program. New Congress comes in, and it seems like NASA, it's such a small percentage of the federal budget, but it's always sitting there, looks like a big ripe target to cut. And you described that, how it's happened over the years, and different projects that are promising and exciting get whacked, different platforms. It's like at NASA, nothing is ever carved into stone.
That's true. And one of the problems that NASA has, I don't know if it's a problem, but institutionally, it makes things difficult. NASA belongs to the White House, just like the Department of the Interior does. So if the president or the presidential administration decides we're going to do this with this national park, that's what happens. And the same is true for NASA. The problem is NASA works on programs that might take 20 years from inception to launch. Well, if you're changing administrations every 4 years or 8 years, and everybody who comes in can have different priorities, you're constantly pushing the reset button every time a new White House comes in, even projects that are very far along. Because there's no money, and because it's so easy to cut NASA's budget, why not? We can spend it somewhere else. There's no political price to be paid for cutting the space program, because people as a rule just aren't engaged with it. It's not something that people feel like touches their lives. Of course, that's not true. I mean, this video call that we're making right now is only possible because of NASA. So, and because it's such an easy target for budget people to redirect money from or redirect money to, it's easy for political games to get played, and what gets approved and what project gets built in somebody's district at the expense of, perhaps a better way of doing things. And we see that with the rocket program right now, for example, the SLS rocket. The engineers and the engineers at Marshall Space Flight Center in Alabama, they're doing the best they can with what they've been told to do. Is that the best way to build a rocket? Being dictated terms by Congress, use this rocket engine, as though anybody from Congress would know the best rocket engine to use, have this amount of lift and this amount of thrust. These are absurd requirements that are imposed on these engineers, but they do their best. But then you have somewhere like SpaceX or Blue Origin, where they're just like, we'll start from a clean piece of paper and build the best rocket we can, the most cost-effective way we can, and we'll do it in the places that are the cheapest. And that's why we see Elon Musk come along and build rockets that launch things into space and then land upright like cartoon characters, or what we used to see in cartoons when we were kids. That's the problem that NASA's facing right now. It still does things the old way, the old political way, but we're living in sort of a dot-com age where things work very differently.
Yeah, you have NASA saying it wants to encourage privatization, commercialization of space, but the proof is in the pudding. They don't seem to be willing to get out of the way. People like Elon Musk willing to put big chunks of their own money into building something, that amazing 50-ish sci-fi looking rocket that would go to Mars. Jeff Bezos, Robert Bigelow, all willing to dump into it, but always run into problems with NASA handcuffing them. Let me ask you this. Are you confident that Elon Musk will be able to get to Mars? No, that's not the topic of your book. You do touch on it, but what do you think about the prospect that he's made some pretty outrageous kind of claims about what's possible? How much stock do you put in him actually doing it?
He's the richest man in the world right now, and so that has great advantages if you want to achieve something. So one of the things about Elon Musk from the very start, the first time he sort of appeared on the national stage, he's able to he makes big promises with very aggressive timelines. He always misses the timelines. He's always late, but they always tend to happen, which is strange and interesting to me. So if he says, I want to go to Mars in the next 10 years, I wouldn't expect to see people on Mars in 10 years. 20 years, pretty good chance it'll happen.
Well, your book, The Mission, is terrific. It reminds us, as you're reading it, it gets exciting. It's exciting. It's the closest thing in the federal budget to adventure, learning something for its own sake, seeking out new frontiers. And, that's exciting stuff. I remember as a kid being so excited about the early space program and eventually Apollo. And I don't understand why there isn't more political support among the public for this kind of adventure. We spend so much money on just junk and crap and bureaucracies. This is just pure science, pure seeking of information and knowledge. And it made me excited about the space program all over again.
Thank you very much. After I wrote the book, after you write a manuscript, it might be giant. It might, I don't know, it was like 600, 700 pages long. My editor took the book that I'd written, and we go in there and we kind of distill it down to its essence. You want just enough story to engage the reader, and not too much where the reader either gets bored or gets lost or whatever. In this case, very quickly, he said, David, what you've written is a heist story. This is more like Ocean's 11 than it is about, government bureaucrats and scientists having meetings. It's a group of people, each with their own talent, coming from different places, different backgrounds, with different skills, and applying their skills each in his or her own way to slowly build this thing up. And in the end, they didn't rob a bank, but they did steal a spaceship.
Yeah. David, thanks very much. I love the book, The Mission, and its gigantic subtitle, by the way, and I hope people check it out. Please keep us in the loop. Let us know what you're working on.
Thank you very much. I'll certainly do that.